Hello and welcome to the video. This video we're going to talk about our numeric data types. We're going to continue to talk on numeric data types. Where we left off from our last video, we explained the 32-bit long. In this one we're going to focus more on the floating point decimals, floating point data types or decimal numbers while we're working with variables and when we can store data or decimal point numbers. Now, in the previous video, we talked about the long, and there's going to be a little topic that we're gonna help to append to this. And I added just the little ranges here to the rest of the ranges that we did. That's the same thing as what we have here. I just added that to the end of this. So in this video here, we'll start talking about the decimal point or floating point data types when storing decimal values. First one we have available to us is the float. Float's a 32-bit IEEE 754 standard. That's just the Institute of Electrical and Electronic Engineers. They come up with this standard in representing decimal points when working with variables or working with, so they're not necessarily variables, but electronics or computers. And now, the first thing we're going to do is declare the variable, and we'll say float, and we'll give it a name. We'll keep the same naming convention, first float. And we'll just initialize it or declare it without actually assigning it a value at this point. So we'll type float again. We'll make our second one. And we'll say float result float. Okay, so now the float's kind of awkward. It's one of these little weird ones that we're working with decimal point numbers, right? So you would think I can just stick a decimal point number in there and everything should be just fine. But in this case, it's not really the way it works. You'll see possible lossy conversion from double to a float. And we'll talk about the double in the next video, but it's kind of like up here when we were working with the integer, or sorry, the byte to the short. It would always try to resolve to an int. Now your int's kind of your go-to. It's kind of the one you're always going to use. When you know you can use these ones, it's good to pick the proper data type to store in. Again, it's dependent upon your hardware and the bulkiness and the runability of your program. Today, again, we don't really have to worry so much about that because our computers are pretty robust and have quite decent hardware when it comes down to it. This was kind of a thing for the old computers, but again, some smaller devices like you're working with an Arduino or like a Raspberry Pi, they may not come with extreme amounts of memory. So you might have to, this will definitely come into be a factor when we're working in something like that. So now the float definitely will hold an integer value. And I want to show you that it actually does resolve to a decimal, very first thing that we're going to do. So when we actually save a value to it, we'll just say result float is equal to our first float, and we'll divide that by our second float. And essentially that's just saying, you know, our first float, which is 9, so that's like saying 9 divided by our second float, which is 6. That's just 9 divided by 6. You might ask, well, why do we do it this way? Well, you need to set up, you know, spots for your RAM to hold data. And technically you're not actually going to assign values like we have been up here. This is just to outline ranges, give you a better understanding of when to choose or when you're going to pick a different one. But in this, you're going to probably get, you know, your data from a user. The user is going to give you input. You're going to store it here. So we set these values up and store our data. So we got 9 divided by 6. Now we'll just do a quick, simple system dot out dot print line. We'll get here, we'll say our float result, and we'll add the result underscore float to the end. All right, now we do have an error here, so if I run this it actually won't work. So just very quickly I'm gonna comment out this line, and now it won't run. So comments are kind of cool. We'll talk a lot about comments because I really enjoy commenting your code. Extremely important when working in groups, but now this line is ignored. So anything in these gray is actually ignored by the compiler, and it's just kind of a something for you to refer back to. Now we'll save this and we'll run it. I'm actually going to click on here. I'm going to hold Alt and scroll up just to give our code a little bit better. There we go. Now maybe you can see it. I don't know if it was too small on the screen. Sorry if it was. I've been writing I've done a bit of videos with it like that. So here, now our result came back with a 1.5. Now it's because we're working with a float. It is actually storing the decimal or floating point number for us. Now it's kind of an awkward thing that we can't actually drop in a decimal here. And again, the double would be, I'll talk more about it in the next one, but it's kind of like the integer of the floating point. It's more of your go-to. The float, considered a single precision. I don't know if I'm spelling that actually right at the moment, but that's fine. It's a single precision floating point data type. So that just it's nothing very important to you. I just write that in there so you can know. But there is a way that we can actually get away with doing this. So if we did say want to put, you know, our number in here, what we can do is typecast it. Now we put these brackets in front of it and we type float in here. You know that what that is saying to this variable is that it definitely is a floating point number. It's a number within range that can be stored within inside of this value. Now if the number was way whacked and way outside of the range, you would just get a different error too. But at this point you can pull this off and you can typecast it and tell the computer that it's absolutely 100% a floating point value. Now another way to actually do this too, so we'll come down here and I'll just 0.67, is what is called a floating point literal. And at the end of our number, we can just type in the F. See, so now that is actually signifying this as well as a float. And it can be a lowercase f, it can also be a capital F. Okay, and if we run this code now, you'll see we run without any errors. Bing. And there we go, we got our floating point value right here. So now that's kind of neat, works out really well. This is kind of not ideal, a little bit extra things to follow when we're doing so, but it can be done and it works well. And that's kind of what I was talking about up here with this. Now the range, when we were talking before, we kind of had this number down here and we said that this was the lowest initialized value that you can technically get away with, because look, it gives us that whacked out error that, you know, number is too large. But in reality, this is actually the true range of a, and I'll show you, if we went with that, you know, we have this here, and it's always going to be a -1 here. When the positive range, it's always, you know, power of 2 to the power of 63 minus 1 is the positive side, and the negative side is -2 to the power of 63. So now you might ask, okay, well then I can come up here and I can type long. Well, no, not technically in this point, but what we can do is actually make it a numeric literal. And if we type it here, now it'll actually resolve it to the long. And I just put the capital L there. You can put the lowercase, but it kind of looks like a 1, so it kind of might freak you out a bit. So we'll just put that there, and I'll show you. Now when we put those there, if we were to, you know, go back into our range, now it's going to be way too big, way outside of the range. We don't have anything to store it in at this point. So that is the technical range that can be done without having, you know, this will be the initialized one without doing any kind of casting or what would you call it, numeric literals. I kind of didn't want to get really into this yet to talk about it, but since we're down here and talking about it, I can now touch base up here with it. So that's kind of what's going on with the float. The float's a weird little variable to work with, or data type to work with, sorry. And it's not overly important to know. We'll get into the one that you're probably going to use for the most part on the regular, but just know that this one is available to you. There may be instances where you actually do need to use it, and that's pretty well it for this video. So I'd just like to thank you for watching. If you have any comments or questions about the video, be sure to leave them in the comment section below. Make sure to subscribe and get the rest of the videos. Check out the rest of the channel. And hope you enjoyed. Catch you in the next video.